Thank you for this opportunity to talk about the project Robot Highways. My name's Simon Pearson. I'm a Professor of Agri-Food Technology at the University of Lincoln. At Lincoln, we specialise in the development of agri-robotic systems. Why agri-robotics? Well, we have an industry that's really under considerable pressure. You've got an agri-food industry that's responsible for between 21 and 37% of all greenhouse gas emissions, uses 70% of all the world's water, fresh water. You've got an industry that's trying to feed an ever-expanding global population, rising to 10 billion by 2050. And you've got all sorts of real challenges on access to labour, not least demographics of age, older populations, lots of fruit and vegetable crops, particularly in the horticulture sector, require lots of manual labour. So demographics of age are working against reducing numbers of coming into the workforce. You've got politics of Brexit, and you've got COVID pandemics, which are restricting access to labour. So we need agri-robotics. Agri-robotics can help us sustainably intensify production. That's trying to get more food out of less resource. So that's the way that you offset some of the environmental challenges, but also it reduces the dependency of the sector on labour, which quite frankly, it's a very, very precious and limited resource, and restricted access to labour is really becoming quite a significant threat to the industry going forward. So agri-robotics are very, very important in terms of how we are going to try to drive innovation in the agri-food sector. At Lincoln, we're very active in this space. We collaborate with a number of robotic companies, including Saga Robotics, and we collaborate with British Telecoms. The focus of our collaboration is a significant demonstration project funded by Innovate UK called Robot Highways. So we're collaborating with British Telecom and a number of partners on a keynote project called Robot Highways. And this slide just shows some of the key partners. So it's led by Saga Robotics, who's a startup, a robotic company based out of Lincoln, and which spun out the Norwegian University of Life Sciences originally, but we've co-located in Norway and the UK. Berry Gardens Growers, who's the UK's largest cooperative of software producers. British Telecoms, Clockhouse Farm, who's a farming partner where we're demonstrating the robotic systems. Manufacturing Technology Centre at Coventry, ourselves at University of Lincoln, and colleagues at University of Reading who are looking at farmer engagement with robotic systems. So what are we trying to do? So it's particularly focused on the soft-fruit sector. It's a very, very important sector in the UK economy. The UK production farm gate level of soft fruit is 450 million a year. It's a great success. That converts to £1.5 billion worth of retail sales. The industry, as I mentioned before, is under huge pressure to do with environmental pressure and labour. It's got a dependency of 30,000 migrant fruit pickers per year, just in the fruit sector alone. That makes the industry very fragile. So if you take away that labour, then it does pose significant risk to the industry. So we need robotics, and what we've been trying to do at Lincoln and with Saga and with BT over the last 3 years is develop very sophisticated robotic systems to meet this challenge. So Robot Highways is a unique project. It's got a number, what we're trying to do is demonstrate a number of solutions in a single demonstration site. So it integrates several years of research. And so what can robots do in agriculture? Well, they can do many, many things. So first of all, number one, what we're trying to do is use robots for logistics support. So robots to support fruit pickers who can call a robot. The robot moves the picker and can take the fruit away. That reduces the amount of walking and downtime for pickers, and we think that can increase productivity by between 15 to 20% just by using AGVs or autonomous guided vehicles for logistics support. Second of all, really excitingly, we can use UVC for disease control. So that's using light as a new way to reduce the incidence of powdery mildew in fruit crops, which is one of the biggest fungal diseases. So it's using light to control the disease, and that's without the use of pesticides. It's a very environmentally friendly technique. That can only be deployed on a robot because the safety issues of humans near UVC, and it can only be applied at night when it's biologically active. So robots have got a unique opportunity to try and control one of the many pests and diseases which affect horticultural crops. Sometimes you might not be able to control all of the pests and diseases with UVC, so you might need to spray the crop, might need some amount of pesticide. So we also have a robot for crop spraying. That's a much, much safer way of spraying a crop than having lots of people around pesticides. 4, we're going to develop robot systems which are integrated into the pack house. So about 20% of the labour on a fruit farm is actually in the pack house packing fruit, and that we can also look at robotising. So we've got some big work packaging robot highways to pick and pack fruit in the pack house. 5, the really exciting thing is robot fruit picking. So most of the labour on farms is deployed for picking. And if we can pick a strawberry, that's a real advance in the state of art of robotics. But that's the one thing that will really reduce the dependency of the sector on labour. So of the 30,000 fruit pickers, we think probably 30,000 workers in the fruit industry, probably about 20,000 of those are picking fruit on any day. So robot fruit picking is the challenge. It's really difficult because you've got to pick that fruit without touching it, therefore bruising it. You've got to have a robot which can recognise the fruit, image it, detect it. You've got to have an arm to move it. It's got to be able to pick that fruit in dense clusters, remove it into a punnet, and then that's got to be on an autonomous guided vehicle to take that fruit back to a pack house. That is a very, very significant challenge, which requires the integration of many, many technologies in terms of delivering that goal. 6, we're going to use robots for fruit detection and forecasting. So if you can image the fruit, you can count them and you can help reduce food waste by matching supply and demand. So count the number of berries, farmer knows how many fruits he's going to be able to sell, and then he can match his sales with his availability of fruit. That reduces waste. So forecasting is going to be absolutely key. Then the really exciting bit is the fleet operation. Already in Kent, we've got 12 robots treating these fields with UV. They've so far done 2,000 kilometres of autonomy since March, so that's working very, very well. But once we scale to get the other 6 applications in, we could have something like 30 or 40 robots in a small farm. That needs lots of fleet coordination. So there's robots need to be able to operate, move, not crash into each other, not crash into people, share vast swathes of data. And we think there's a real opportunity for 5G and telecoms as a critical enabler for the infrastructure for moving data around the farm. So we're working very closely with BT on 5G and how we optimize the telecoms around the farm for a new farm with vast amounts of data being generated. And here you go, just a systems diagram, and it just shows what we're trying to do. The other things with just the top left, one of the great things about robots is they're electric, so we can power them with renewable. We don't need fossil fuels, and there's a huge amount of digital architecture that needs to be put in place, which is moving data around the farm and around the system so that we can make better operational decisions, better decision support for farmers. So each one of those robot applications has an application. When you integrate them all together on a big scale through multiple applications, that's when you get the real leverage. That's when you get the real gain from robots. And that's what we're trying to demonstrate on a real farm, Clockhouse Farm, through robot highways. And just to show you some of the technologies that's going on here, this is on soft root robotics. I'm going to give you a flash through a 3-minute overview of robotics. These are the robots we're using. It's a 4-valve robot made by Saga. So really, it's a fantastic robot. It's a lightweight robot, weighs about 150 kilos. It's got battery life about 8 hours on normal load. You can scale them, so they're quite easy to build, so you can have a rather large number of them. This is a number in a field, just showing their operation. They've got high torque motors, so they're good for agricultural purpose. and four-wheel drive, so you can see how easy and maneuverable these robots are. So a really good lightweight vehicle. Now, how do we actually make these things work? So the first thing we do is we focus on autonomy, and we have at Lincoln a robot fruit farm where we trade most of these robots to operate. And the first thing we've done is autonomy. And this just shows the robots moving around the farm. You can see the top pane is what the robot views of the world, and the bottom pane shows the robot in the real world. So we've trained a very, very sophisticated autonomy stack at Lincoln. And then we've, with Saga, we've then applied this in Kent. And this just shows the UVC robot at night going up and down a field in Kent. And that's what it looks like. And we've got 12 of those robots operating day and night now in Kent. And they have been doing that since March very successfully, completely autonomous. As I say, you can use them for logistics support. This just shows the fruit on a robot in a field situation. And what I'm going to show is some of the sophisticated control system in a minute. And this just shows how it works. So there's a picker on the left with a mobile phone on a trolley. Picker hits that phone. We then localize where the picker is and send the robot to that person. Now, the localization is going to be incredibly accurate. And that robot's going to navigate through very, very narrow spaces. So here's two pickers picking away, moving to the left. And we're going to see some robots appearing any minute. They're going to call it. There's robot 1 called. There's robot 2 called. So they found the picker and then gone back. And they're taking that fruit back to the pack house. That's logistics support. And then next up, we're on fruit picking. And this just shows one of the prototype picking heads that we're working on, or Saga are working on for their robots. We have a cut picker, which basically swallows the fruit. So it picks them without touching them, and there's a small knife inside that picking head, which then trims the stem, and you've got the fruit. So that's advancing very rapidly. If you can pick them, you can forecast them. We're developing a product called Fruitcast, which has got forecasting. This is using advanced machine learning and AI. And this just shows the image analysis system detecting the fruit. It's not only detecting them, it's counting them and also weighing them, sizing them, estimating their mass. So a whole range of different technologies which have been deployed, and all these are going to be deployed in the Robot Highways project. Project's, I think, a £2.8 million project funded by Innovate UK, and arguably one of the largest demonstration projects for agricultural robots in the EU at the moment. So that's a good overview, hopefully, of the Robot Highways project. We're now working on multiple applications, really to focus on this fruit picking challenge to try and reduce the dependency of the sector on labour, but we're also working on a range of projects on using robots in field environments for weeding, for using robots to advance the speed of plant breeding, and all sorts of other applications in agriculture. So that's it from me. So thank you for listening, and absolutely delighted to be involved in the Tommy Flowers Network, and look forward to next steps. Thank you.